Hello viewers, welcome to another educative episode of Legacy Moments. My name is Peter Andrew Official. We are currently in the physics lab. We are having an electricity practical. Join us in the class.
Alright, good afternoon students. Good sir. Alright, so today we are going to be having a practical on electricity. Alright, as you can see, we already have the questions and everything on the board. So all we simply do is to follow everything we have on the board systematically. Alright, now first of all, if you see the diagram given to us, now we have X here. Now X is a standard resistor. Standard resistor in the sense that throughout the experiments, we are not going to alternate it, we are not changing it. And we are using 1 ohms resistor for X, which is this. We have a 1 ohm resistor, that's what we're going to use. It's called a standard resistor. It's not variable, we are not changing it. It's going to be fixed throughout the experiments. Then this is a cell. Cell, that's a battery. We are going to be using this. This is going to be our battery. Alright, this 1.5, this 1.5 volts, making it what? 3 volts. Alright, now this is our key. Alright, as you can see, this is the key here. Alright, this is the key. Whether you call it key or you call it what? Switch. Alright, now this one, what we have here, this arrow, it's a resistance box. Alright, this is the resistance box here. As you can see, we have 5, 2, 2, 1, 100, 50, 20, 20, and what? And 10. These are what? Our resistance box. And this is our what? Our ammeter. Ammeter is used for reading currents. Now this is the ammeter. As you can see, the ammeter we're using is from 0 to 2 ampere. It's from 0 to what? 2 ampere. That's what we're going to use for the practical. Alright, now let's go. Now they said measure and record EMF of the accumulator. Accumulator is simply the battery, which we have done already, which is 2.98 volts. That's the voltage for this. All right, good. Now they said connect a circuit as shown in the diagram above. All right, they said X is a standard resistor, which is this, which I showed you before, which is this one. It means we are not going to change this. We are using a 1 ohm resistor. That's the X. An arrow is a what? Is a resistance box, which is this. This is the resistance box we have said before. Alright? Now they said the first thing is this. They said with arrow is equal to 0 ohms, close the key K, which is this. Read and record the ammeter reading and evaluate I inverse. I inverse simply means 1 over your current. Okay, so what we are going to do now, I'll show you on how you do the connection and everything. Alright, so first of all, if you are doing any practical electricity, you follow it the way it is on the diagram. Any practical electricity, on the electricity you are doing, you just follow it the way it is on the diagram. That's how you make your connection. Just the way it is, okay? Now, if you want to start, now I have this, I can start to start from here. Alright, now this is my standard resistor. Alright, now for my standard resistor, you see that I have a wire coming straight to the key. While from the other part of the standard resistor is going to the what? To the battery. So you see what I have here. This is my standard resistor. Look at it. So first of all, there's a wire going straight to the what? To the key. Alright, standard resistor straight to the key. So this wire you are seeing here is this part. From the standard resistor straight to the key. Alright? Then from the key is going to the what? Resistance box. So this is from the key going to the what? Resistance box. That's from here to the resistance box. Then from the other part of the resistance box, which is this, you see it's going to the what? Ammeter. So that's this one coming to the what? Ammeter. Alright? Then from this ammeter we're having here, that's from the negative part of, because if it goes like this will be the positive part, and this will be the negative part. The reason why it is negative because it's coming to the negative part of the battery. So it means from the negative part of the ammeter, which is this, I will also take it down to the negative part of the what? Of the battery. So it means if I want to take my measurement, I will take this to the negative part of the battery, and I will take this to the what? Positive part, because from the standard resistor you see this wire here is going to the positive part of the battery. Then from the ammeter, this part is coming to the what? Negative part of the battery. So you see, so I'm going to do my what do you call it, my evaluation just like that. Take the connections just the way it is on the board, just the way it is on the diagrams, just like that. It's very simple and straightforward. Okay. All right. So let's see something. So the very first one is this. I said with arrow is equal to 0 ohms. Close the key K. Read and record the ammeter reading and evaluate this. Now this is the key. Now the way the key is here, the key is opened. Alright, and if the key is opened, we know that current will not work, will not flow. Is it not? Yes. So when I want to take my reading, I'll close it, take my reading. As I'm done taking the reading, I remove it again. I remove my key so that current will not be flowing. I will not be wasting everything. So when I want to take my reading, I close, take reading. As soon as I'm done taking the reading, I open again. Alright? If I want to take my next reading, same thing, close, take my reading. As I'm done taking the reading, I open again. Just like that. Okay? Okay, now let's start now. I think I need 2 students. Come and take the readings for us. Now, okay. You come. You come. Alright, so the first thing you do, you take the reading when arrow is 0 ohms. 0 ohms in the sense that all the keys here will be closed. Everything here will be closed. You take the readings. Alright? If I should remove one here, it means I'm trying to take the reading when the resistance is what? 1 ohms. If I remove this, I'm trying to take the reading when the resistance is what? 2 ohms. So if everything is closed, it means I'm trying to take the reading when the resistance is what? 0 ohms. So it means if I want to take the first reading, everything here should be closed. So that's the first thing they ask us. Alright? So with the key closed, now with the key closed, I want to take my reading now. So start, take the reading. Put your this to the positive part of the battery, put down the negative part of the battery, then you close the key. Place it, then you close it. Oh yeah, close your key. And you see there's a deflection now, right? Alright, so you take the reading from there. That's give us what? The up part, that will be what?
0.7. 0.4.
0.4. So it means when our resistance is 0 ohms, the current is what? 0.4 ampere. Is it not? Good. We evaluate this. So now you have done that, which is the first part. Now the next part is saying when the resistance is what? 1 ohms. So this I said after taking the reading, I will remove my key. Now if you see after I remove my key, you see the thing has gone back to 0 because current is no longer flowing. You understand? Go to the first one. So now the next thing, we try to get the reading when the resistance is 1. So what you do, you remove 1 ohms from there, close your key, and you take your readings. That was what?
0.3.
0.1?
3.
Alright, so 0.30. Alright, so the next one is 2 ohms. So you remove 2 ohms from there, remove 2 ohms, close your key and take your readings. That's what?
0.24.
0.24. Good. 0.24. Alright. So to get 3, you remove 2 and 1. So remove 1, remove 2, close your key and take your readings. That's what?
0.23.
0.22. Good. Alright, so to get 4 ohms, you take 2, remove 2. That's okay. This is 2. Okay. Close your key and take your reading. That's what?
0.21.
21. Okay. It's going down. Alright. Then 5 ohms. You remove 3 and 2. Close this. Or you can just remove 1.5 since there's 5 there. Close everything there. Then remove 5. Remove 5, make sure the battery is well connected. Remove 5, remove 5. You removed 5 already. Alright, close it. What is it there?
0.18.
Alright, 0.18. Now if you see, the value of the current is going. So what does that tell you? That the higher the resistance, the lower the current will flow in the circuit. Is it not? So from there, we evaluate the value of what? I inverse. I inverse simply means 1 over I. So let's go. 1 divided by 0.4. 0 what? 2.5. 1 divided by 0.3.
3.3.
3.3. 1 divided by 0.24.
4.17.
1 divided by 0.22.
4.5.
1 divided by 0.210.
4.7.
1 divided by 0.18.
5.56.
Alright, so we've gotten the values we need. We have our I, we have I inverse, we have arrow. Now let's see the question. Now they said plot the graph of arrow against I inverse. So it means if you're asked to plot the graph of arrow against, so it means your graph will be like this. It means I will have my arrow here in ohms. Then we have my I inverse in what? Ampere inverse. So that's the meaning. Alright, so it means my resistance will be on the vertical axis, while the I inverse will be what? On the horizontal axis. Alright, now they said determine the slope x. After plotting your graph, you get your slope. And find the what? Intercept. Alright, where the line intersects with the arrow of the axis. Okay? And it says state 2 precautions taken to ensure accurate results. Alright, now if you want to take a precaution, now listen, if you want to take precaution on this, what are the precautions you took when taking the results? It says state 2 precautions taken to ensure accurate results. So what are the precautions we took when taking the results? Alright, you?
You have to ensure that the connections are tight.
Alright, very good. That's one. Ensure the connections are tight before. Alright, you also?
I ensure the key is closed before reading.
Alright. Ensure the key is closed before taking readings. Is it not? Yes. Alright, so with this we have come to the end of the practical. Thank you and God bless you.
As a parent, I have always asked, how can I prepare my children for the infrastructural development and socio-economic evolution of the next decade? With the ongoing speed of globalization, how can I position my children to perform excellently in a rapidly changing society? The answer is and has always been to give them a solid foundation. Academically, spiritually, and morally. Salvation International Preparatory Schools, with her team of highly qualified tutors, conducive environment for learning, state-of-the-art computer and science laboratories coupled with quality day and boarding facilities, is the place to be. For more information, contact 080-233-76135. SIPS remains the birthplace of leaders.
Thank you for staying tuned. I knew it was educative. Bye.
Salvation International Preparatory Schools. Salvation International Preparatory Schools. A place